And welcome to the Tejano Virtual Events Happy Math Hour. These are your weekly interactive math reviews for Math 1332 and Math 2412, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it later. Also, it is recorded so others who may have missed out on today's events will be able to come and watch it. Thank you so much for attending. And so now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. Without further ado, here is Ms. Yvette Chuca. Also, if you are here for the Math 2412 review, go ahead and click on the link that's going to be provided to you shortly so that you can go ahead and attend that presentation.
Hello, everyone. Happy Friday. We're going to get started here. Let's see. They're putting the link for 2412 if you need that link. And I guess we'll get started. So today we're going to cover the arguments and Euler diagrams, and then we're going to do a review of chapter 3. At any time, if you have any questions, please let me know. Okay, so an argument is basically it involves sets whose elements are described using the quantifiers all, some, and none. And so what we're going to be looking at is creating Venn diagrams that are either going to be in one of these 4 ways. Okay, so if we start with the word all, then this would represent that argument. So in this argument, we see that all p's are q's, and that's because all the p's are inside of the q circle. In the second one, no p's are q's, and notice that the 2 circles are disjointed. They're not touching each other, and so none of the p's belong in the q's. And then some p's are q's. You can see that they intersect here with some of the p's being q's. And then in this picture, it almost looks the same as the one before, but here we can see that there's still some p's that are here, but there's some p's that are not q's. So like this p is not a q. In this third picture, this p is a q, okay? So here we want to determine if the argument is valid or invalid. And so what we're going to do is use an Euler diagram. And so here we have the first premise, all college courses are fun. And then the second premise, this course is a college course. Therefore, remember the 3 dots represent the word therefore. This course is fun. Okay, so the first thing you want to do is determine how many circles we're going to be using. And so we're going to need a circle for college courses, and we're going to use a circle for fun. So I'm just going to label them as college course and the word fun. Next, we need to decide which of these Euler diagrams are we going to be using. So in the first premise, we have all college courses. So that means that we're going to be using something that looks like this first picture, right? So it could either be where the fun circle is inside or the college circle is outside, or it could be that the college course circle is inside and the fun one is outside. So we need to determine which of these is the correct one. Okay, so let's continue. And so here, all college courses are fun. So we're going to be looking at the one on the right. So let me go ahead and highlight it. I had some highlight here, but I guess it didn't come over when I saved it as a PDF. So we're going to be using this one here. Okay, so all college courses are fun. That means the college course circle needs to be in the inside of fun. So now we go to premise 2. This course is a college course. So you want to think about where can I put premise 2. And so this college course is a this course is a college course. So this dot is going to represent my premise 2, my second sentence. And so now we are still looking at this Venn diagram here. You can ignore the one on the left. And so now we want to see, well, if we look at the conclusion, this course is fun. Since the dot is inside of the college course circle, which is inside of the fun circle, then our conclusion seems to be valid, okay? But before we make any final conclusions, you always want to ask yourself, is there anywhere else that we can place that second premise? In other words, this dot here, would I be able to place it anywhere else? And one other thing, let me just go ahead and draw one more thing here really quick. Our circles, these should be in a Venn diagram. So just remember that for any of the problems we do right now, we should have a box around our circles. Okay. So your question is, can this dot be placed anywhere else in here? And the answer is no, right? Because the dot has to be in the college course, because the second premise tells us that the course is a college course. So there's no other place for us to put it. So because we can't put it anywhere else, then the argument is going to be valid. Okay. And you'll see examples where that's not the case. So here's another one. All lawyers drive BMWs. Suzanne is a lawyer, therefore she drives a BMW. So let's look at our circles. We need one for lawyers, one for BMW. And we need to decide how are we going to draw our circles. Since we start with the word all, that means that we're looking at this first one. So we're going to have to combine these one inside of the other. So you need to decide which one is the correct picture here. So all lawyers drive BMWs. This first one says all BMWs are lawyers. So that's not going to be our answer, right? We're not going to use that one. So this doesn't make sense. So the one we are going to be using is that all the lawyers drive BMWs. So all the lawyers are inside of the BMW circle. And then we'll go to premise 2. So let me just cross out the one we're not using. So we're not using this one. All right, so Suzanne is a lawyer. So we're going to place Suzanne as our lawyer inside the lawyer circle. Okay, so we have Suzanne is a lawyer, so she goes in this lawyer circle. And so if we look at the conclusion, Suzanne drives a BMW. So the way we have drawn it, this tells us that Suzanne is a lawyer and she drives a BMW since she's in the BMW circle. But don't forget, always ask yourself if you can place that second statement anywhere else. So your goal is, one of the things you want to ask yourself is, can I draw my picture so that my conclusion is not true? And if you can, then that means that the statement is going to be invalid. Okay. So here we cannot put Suzanne anywhere else. So therefore, this statement is going to be valid. Okay. Let's do a couple more. No prime numbers are negative. The number 7 is not negative. Therefore, the number 7 is prime. All right. So let's decide how we should put our circles. We have 2 circles, prime number, negative, and then we're going to use the number 7. So it says no prime numbers. So we're looking at this second option here. Okay, so we're going to keep our circles separated. So then what we need to figure out now, let me just draw this. Okay, so what we need to figure out is go to the second one. The number 7 is not negative. So where do we place 7? Okay, so if it's not negative, it cannot be in this negative circle. So some of us, our first reaction is going to be to put it in the prime number since it cannot be in the negative circle. Okay, but don't forget, what's that important question? Can you draw your picture in a different way so that your conclusion is not true? Okay, in other words, is there anywhere else that we can put 7 so that the number 7 is still not negative? Well, we can still put 7 on the outside, right? So if I put 7 here, let me just draw my box. So if I put 7 out here, this is still true that the number 7 is not negative, right? So it's still okay. But now is our conclusion true? The number 7 is a prime number. Well, it's not in the circle. So in this example, we were able to draw our answer. Let me see if I have it. Okay, I don't. So we were able to put it here, or we could also put the 7 could also be in here. Okay. Since you can put it in both places, then we say that the argument is invalid since you were able to place it in two different positions. Okay. I think I have maybe one more of these, if not two. So no mathematics professors are good looking. All good looking people are models. Therefore, no mathematics professor is a model. All right, so let's check the validity of this statement. So here we need a circle for math professors. We need one for good looking, and we need one for model. So here's my 3 circles. And so we'll start with premise 1. No mathematics professors are good looking. So for premise 1, our circle is going to be a disjoint, so they're not going to be together. Okay, so we're going to have our math professor and good looking circle not touching. And then the second premise, all good looking people are models. So since it has all, that means we're going to be working with this first one. So we need to draw all good looking people are models. So we need to decide, is good looking going to be on the inside or on the outside? Okay, so we need to decide, is it this way or this way? So all good looking people are models. So the correct one that we're going to use is that third one. Okay, so all good looking people are models. And so now what we have is these two situations, right? So the first premise, you have your math professor and good looking circle. They're not touching. And then you have your second premise, all good looking people are models. And so if we look at our conclusion, therefore no math professor is a model. Okay. So by looking at our picture, we can see that, let me just draw my box. We can see that in this situation here, our conclusion works, right? No math professor is a model. But don't forget your question you want to ask. Can you draw this picture in a different way so that your conclusion is not going to be true? And so if we continue, then I could draw my circles. Let me see if I have it here. Yeah, I could draw my picture like this, right? And notice that my math professor circle and the good looking, they're still not touching. The math professor and good looking are not touching. And our good looking and model is still valid right here. But now what happened is if I draw it in this way, then I can see that some math professors are still models, okay? Which is gonna make this not true. So our conclusion that we can make is that this is invalid because we had two different ways that we could draw our conclusion. We could draw it like this, or we could draw it, let me go back, oops. Or we could draw it like this. So since you found a second way, then you make your statement invalid. So always if you can draw it a second way, your conclusion would be invalid. All right, so now we're gonna start reviewing for your tests. So that those Euler diagrams were from 3.6, and so now we're just gonna go over some of the stuff that we've done for chapter 3. So the first question, determine whether each statement or each sentence is a statement. So the first one, look for a cat, and then the second one, Clark Kent is afraid of the dark. So remember, in order to be a your sentence should you should be able to identify it as false or true. Okay. So look for a cat is not a, you can determine if that's true or false. It's more of a command. So this is not a statement. Clark Kent is afraid of the dark. So even though I don't know who Clark Kent is, I can determine if he is afraid or if he's not afraid. And so this would be a statement. All right, so now let's go to determine the truth value of each statement given that P is true, Q is false, and R is true. So here we don't have to draw a truth table. All they want us to do is basically if they're telling us that P is true, Q is false, and R is true. So what we want to do is under our statement here, we can enter these values and then go ahead and figure out what they are. So let's go ahead and do that. So here I have P is true. Negation Q, well, if Q is false, then the negation of that is going to be true. So I have P is true, the negation of Q is true. And then I have negation of R. So if R is true, then the negation of R is false. So I put false, and then Q is false, so I put false. And so now I can evaluate this. So we have true or true. So whenever you have a disjunction, if they're both true, it's going to be true. And then here we have false and false. So with the conjunction, since they're false, then this is going to be false. And so true and false would be false. Okay. So now let's go to the next one. So for the next one, it looks like a longer statement, but we still work it out the same way. So we have R. So we're going to enter what R is. And R is true. Negation P. Well, if P is true, then the negation of P would be false. So I write false. And then I'm just writing down my symbols, right? So right now I'm not evaluating or anything. I'm just writing down our symbols so that it's easier to view them together. So now P is true. And then we have disjunction negation Q, which we said was true. And let me see, I think I put the wrong one here. So let's check it again. So P is true. And then the negation of Q, that should be a true, right? So let me go ahead and draw it here. So that's going to change our problem. So the negation of Q is true. So we'll make this a true. And then we have Q is false and R is true. So everything else is okay. So I'm not going to continue with the slides. I'll work it out here because the rest of the slides, we would have to change it every single time. So we'll just do it here. So we have true or false. That's going to be true. And then we're going to have disjunction. True or true is going to be true. So then we have true or true is going to be true. And then this is going to be the biconditional. And now we have false conditional true is going to be true. And so this is true. So we have true biconditional true, which is going to be true. So if they're the same, then we get true. Okay. So again, I'm going to go ahead and click on it. And we still ended up with true. but there was a mistake here. So just be careful with that. All right, so next we're gonna construct a truth table. Okay, so to construct the truth table, we need to figure out we're working with two statements. So we're gonna add our two columns here for P and Q. So for P, we get true, true, false, false. For Q, we get true, false, true, false. And then I'm going to go ahead and enter what P is. P is true, true, false, false. I'm going to call it number 1. Negation Q is false, true, false, true. I'm going to call that number 2. And then I'm going to use 1 and 2 to give me 3 for the conjunction here. Okay, so we have true and false gives me false. True and true gives me true. False and false gives me false. And false and true would give me false. So that's our number 3. But then I have the negation of this parentheses. So what we want to negate is number 3. So we'll do that next. So if I have false, the negation would be true. If I have true, I get false. False gives me true, and false gives me true. So now I continue on, and I'm going to call the next one 5. So Q is true, false, true, false. And then P is true, true, false, false. So I'm going to use 5 and 6 to give me the conditional here. So true, conditional true is true. False, true is true. True, false is false. And false, false is true. So that's your number 7. So now we're going to do the disjunction here. And you want to use the last numbers on the left and the last one on the right. So we're going to use 4 and 7 to give us this middle column. Okay, so 4 is true, or so this is true. With true is going to be true. False with true is going to be true. True with, okay, so let's see here. So true with false, that should be what? Let me change it. So true with false, that should be false. And then we have true and true, which is true. Okay, so we end up with true, true, false, true. Okay, so if they're all true, like if we were to get all 4 truths, and if your question is asking, is this a tautology? Then we would say yes, if they were all true. Okay, but since there's one that's false, then this is not a tautology. Okay, so the next thing is use one of De Morgan's law to write an equivalent form. So Ellie did not eat breakfast and she did not take a lunch break. So first we want to remember what De Morgan's law is. So here's the definition. And so now we can take our statement and translate it into symbolic form. So here we have, let's let P be Ellie ate breakfast, and then we'll let Q be Ellie took a lunch break. Okay. So if I translate this, Ellie did not eat breakfast, I can call that negation P. And, so here's my symbol for and, conjunction. She did not take a lunch break, that's negation Q. So this sentence in symbolic form is this here. So if I look at De Morgan's law, then I can see that we're working with this first one. So an equivalent form would be the negation of P disjunction Q. And so now I just need to translate this symbolic form into a sentence. Since the negation is on the outside, I can start with it is not true. And then P is Ellie ate breakfast or she took a break. Okay, so that would be our answer. So going from a sentence to symbolic form will make it a little bit easier to see what we need to write. Okay, so let's look at the next one. Use a truth table to determine if the statement is valid or invalid. Okay. So for this one, we have premise 1 and premise 2 in our conclusion. So remember, when you're trying to determine if it's valid or not, what you want to do is you want to write premise 1, and premise 2, and then you have your conclusion, and then your conclusion. Okay. And so we're going to write that into a truth table. And so here is, let me just write down oops, I chose the wrong thing. Let me write down the premise so you can see it. Okay, so this is premise 1. This is premise 1. This is premise 2. And then you have your conclusion. Okay, so my P column is true, true, false, false. My Q column is true, false, true, false. And so we'll just fill in this truth table. I'll do these first 3 steps here. So P is true, true, false, false. Negation of Q is false, true, false, true. And then the conditional here is true, false gives me false, true, true gives me true, and false, false gives us false, false, true gives me false. Okay. Now I'm going to do the next set of parentheses. So negation P is false, false, true, true. Q is true, false, true, false. And then the conditional here, false, true is true. False, false is true. True, true is true. And true, false is false. So I'm going to use 3 and 6 to give me this conjunction. So I have false and true is going to be false. True and true is true. False and true is false. And false is false. Okay. So now I'm going to write down what P is. So P is true, true, false, false. And I'm going to use this last column 8 with my last column over here 7 to give me this number 9. So we have false and true is false. True and true is true. False and false is false. False and false is false. And then I'm going to fill in negation Q next. So negation Q is false, false, true, true. So that's your 10. So we're going to use our 9 and our 10 to give us 11. So we have false with false is true, true, and make sure I have the right one here. So we have false and false is true. True and false should be false. This one should be false here. So I'll change it right now. False and true is going to be, false and true is going to be true. So I have it backwards here also. Okay, let me just change them right now. All right, so let me circle them too because there's so much stuff going on, right? So we have this false with the negation of Q, which is this false. And that gave us true, so that's okay. And then we have this true with this false. And that should give us a false. Okay. And then I have this false with this true. And that's going to be true. This should be true. And then we have this false with a true. And then that should also be true. So I'm not sure why I didn't have them right. Okay, so whenever we're doing these to determine if it's valid or not, you have to look at when your first premise is true. So that's why I circled this one here. When your second premise is true, and so that's why I circled this one here. And then you look at the conclusion, and if your conclusion is true, then your statement would be valid. Okay, but in our case here, we have true and true, but it gave us a false, so then that would make it invalid. Okay, so again, you only look at when the premise is true and when the premise is when both premises are true and your conclusion is true. Okay, so let's try another one here. Okay, so on this one, it looks like some of my writings didn't come through. So I think, I guess we can work it out. Or let me see. Oh, here it is. Okay. So let me we can just go through from here. So the first thing that we want to do is fill in these columns. You have 3 statements. So your P is going to be true, 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 4 trues and 4 false. And then your Q is true, true, false, false, true, true, false, false. And then your R would be true, false, and true, false, true, false. So you alternate on the R. And so your first premise is R, which is right here. Your second premise is P conditional negation R. And then your third one is negation P conditional Q. And then your conclusion is P and Q. So I'm going to fill in R first. So I have true, false, true, false, true, false, true, false. And then I'm going to fill in this parentheses here. So P is true, 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 false, false, false. Negation R is false, true, false, true, false, true, false, true. And so you want to use these two to give you this one. Okay, so you have true, false is going to be false. True, true is true. True, false is going to be false. True, true is true. False, false is true. False, true is true. False, false is true. And false, true is true. And so now that we have 4, we're going to use 4. And then we can use 1, okay, to get this 5. So we have true and false. It's false. False and true is false. True and false is false. False and true is false. And then true and true is true. And then false and true is false. And then we have true and true is true. And false and true is false. So 5 is your last column that we've done so far. And now I'm going to do this parentheses over here. Negation P is going to be 4 false and 4 truths. And then Q is 2 truths, 2 false, 2 truths, and 2 false. So I'm going to use these 2 to give me this one. So false, true is true. False, true is true. False, false, it's true. False, false is true. True, true is false. True, true is true. And true, false is false. True, false, it's false. So now we are going to use 8 with the last thing we did over here, which was 5. So 8 and 5. So it's this one and number 5. So we have false, true is false. And then false, true is false. False, false is false. False, false is false. True, true is true. And then true and false is false. And where am I at? Okay, so true and false is false. False, true is false. And false, false is false. So number 9 is our last column that we did. So now we'll do 10. So 10 for P is 4 truths and 4 false. Q is 2 truths, 2 false, 2 truths and 2 false. And then we have true and true is true, true and true is true, true and false is false, true and false is false, false and true is false, false and true is false, false and false is false, and false and false is false. Okay. So now we have 12, and we're going to use number 9 to get our answer. So we have false and true is true. And then where you really care about is where they're all true, right? Where your premises are true. So this is really the only row that matters right now is the true, and the true here. So this is true for this premise is true, and this premise is true. And so we look at that answer, then we have false with true, gave me a false. So then this whole argument would be invalid because our final answer here for that row is false. Okay. So again, you only want to look at when the premises are true, and they all have to be true. So 1, 2, 3 are true. If you go through the rest here, we won't see any that are all true. Okay, so that would be your answer. Let's go to the next one. Valid or invalid. So no wizard can glow in the dark. Some lizards can glow in the dark. Therefore, no wizard is a lizard. Okay. So here I have no wizard. So I need a circle for wizard and one for glow in the dark. And it says no wizard can glow in the dark. So they're going to be a disjoint here. So they're not going to touch each other. And then some lizards can glow in the dark. Okay. So some lizards can glow in the dark. So let's see. I don't have it here, so we'll draw it here. And so some lizards can glow in the dark. So I can draw my lizard circle here. And that tells me that some lizards can glow in the dark. Okay. And if I look at the conclusion, it says no wizard is a lizard. So no wizard is a lizard. And so by looking at this picture, no wizard is a lizard. So therefore, it must be valid. But what is the most important thing you should ask yourself here is, can we draw this picture so that it's different? Okay, so that I can make this conclusion false. Well, we could try. So let's see. So we have our wizard circle. So this is our wizard circle. And then we have our glow circle. I'm just going to call it G. And then some lizards can glow. Well, I can make my lizard circle something like this. So this is my lizard circle. And so here I can see that some lizards are still glowing, right? But now some of those lizards are wizards, right? So there's these guys here that are lizards and wizards. And so since I can draw I can make this argument, I can draw it in two different ways and still keep the premises true, then this whole thing would be invalid. Okay, so this answer is going to be invalid. Invalid. Okay, so that was some examples of what we've been covering the last 2 or 3 Fridays. And let me go back to one of the truth tables. Since we have time, I just want to double check it because I didn't feel comfortable. It should be it should have been a valid statement, I believe, but let's double check it. Let's double check this one. And I'll go from the beginning just to make sure that everything was okay. So my recommendation is use paper, make a box, write neater, right? Because if not, then you could be reading the wrong columns with the wrong rows. So let's see. So we have our statements. Everything is copied. Okay. And then and P, and then your conclusion. Okay. And then this is okay, and this is okay. So P is true, true, false, false. Negation Q is false, true, false, true. So that's okay. And then true and false is false. True and true is true. And false is false. False and true is false. So that is all okay. So let's check the next set here. Negation P is false, false, true, true. And Q is true, false, true, false. So false and true is true. False, false is true. True, true is true. And true, false is false. So all of that is okay. And now this one here, false with true is false. And true with true is true. False with true is false. And false false with false is false. Can anybody else not see what I'm looking at right now? Can you guys see what I'm sharing right now? Just want to make sure. Okay. So so far everything looks okay. So up to number 7, we're good. Okay. So now let's go with the next group. So for P is true, true, false, false. So now I'm going to use 7 and 8 to give me this final answer for this. So we have false and true is false. True and true is true. False and false is false. And false is false. So number 9 is okay. All right. So far so good. And now we're going to go with negation Q. And let me see if we can erase that. All right. So, all right. Oh, I thought I erased it. Okay, let me try again. I don't know. Okay, well, I was trying to erase it, but I guess it didn't let me, or I don't know how to do it. All right. So negation Q is going to be false, false, true, true. So that's okay. And we're going to use this one. So false and false is going to be true. And then true and false is going to be false. So that's okay. And then false and true is true. And false and true is true. And then the one that we're looking at is this one and this one, which gives us false. So no, so it's okay. So invalid. So this is going to be invalid. And let me just write invalid. In case you're going to go back and review this. All right. And so that's all that I have for you today. You're welcome to ask us any questions. We have a few minutes we could answer. And good luck to you all in your exams if you're having them next week. And then starting the next happy hours, we'll be looking at numeration systems. So if you have any questions, feel free to ask us. If not, then that's it for today.